All right, let's dive in. We're about to go on this absolutely incredible journey. I'm talking 4.6 billion years of history, all the way from a simple cloud of cosmic dust to the amazing living planet that we call home.
I mean, have you ever really thought about it? How did a boiling, seething ball of lava turn into, well, this, the Earth we live on today? Where did all our water, these massive oceans, even come from? And what's the deal with the moon? How did it get there? Well, stick around because those are exactly the questions we're going to tackle.
Okay, so to start, we have to go way, way back, like 4.6 billion years ago. Picture this, a vast, quiet, dark corner of space. This is where it all begins. Not just Earth's story, but the story of our entire solar system. And it all started with something called the solar nebula. It was basically this huge, ancient cloud of gas and dust, mostly just hydrogen and helium, the most basic building blocks of the universe. But from this cloud, literally everything in our solar system was about to be born.
So this nebula was just drifting for ages, just floating along peacefully. But then, bam, a nearby star goes supernova. It explodes in this spectacular, violent event. The shockwaves from that explosion slammed into our quiet little nebula, causing the whole thing to start collapsing in on itself. As it collapsed, it started to spin faster and faster, flattening out into a huge disk. And right there in the super dense, high-pressure center of it all, nuclear fusion ignited. And just like that, our sun was born.
And get this, the sun is an absolute beast. Its birth was so intense that it gobbled up 99.8% of all the material in that original nebula. Just gone. That means everything else, every planet, every moon, every single asteroid, all of it had to be built from the tiny 0.2% of stuff that was left over. Just the scraps, really. So what happened to that leftover material, that 0.2%? Well, that's where things get really interesting. That's where the planets come in. The whole process of building planets comes down to one key idea: accretion. It's a fancy word, but it's pretty simple. Think of it as gravity's construction project. It's just the process of stuff sticking together, pulling in more stuff and growing bigger and bigger. It's the universe's recipe for making planets. So it starts super small. You've got these tiny little dust particles just bumping into each other and sticking like cosmic dust bunnies. Over millions of years, these clumps grow into bigger, kilometer-sized chunks we call planetesimals. And then gravity really takes over, pulling these planetesimals together to form even bigger, moon-sized bodies called protoplanets. These are basically baby planets, the early versions of Earth and its neighbors. Now, you might be picturing a nice, peaceful, newly formed Earth. But no, not even close. Early Earth was a nightmare, a total world of fire. We call this period the Hadean Eon for a very good reason. Yeah, Hadean, as in Hades, the Greek god of the underworld. And trust me, it lived up to the name. This wasn't a short phase either. For 600 million years, our planet was just a molten ball of lava, getting pummeled nonstop by asteroids and other space debris, just pure unimaginable chaos. Seriously, try to picture it. No solid ground anywhere, just a global ocean of boiling magma. If the surface even tried to cool down and form a crust, wham! Another massive impact would come along and melt it all over again. It was just relentless. So that brings up a huge question, right? If the whole planet was a sea of fire, where did our oceans come from? How do you get water in a place like that? Well, funny enough, the answer is found in the chaos itself. It's kind of ironic, actually. Those same comets and asteroids that were smashing into Earth and keeping it molten, a lot of them were packed with ice. So they were basically cosmic water balloons, delivering water with every impact. But that's not the only source. A lot of water was also trapped inside tiny crystals, baked right into the planet's original minerals from the very start. And as if a constant bombardment wasn't enough, this insane, chaotic period also gave us one of the most important features of our planet, the moon. And its birth story is, you guessed it, incredibly violent. For a long time, scientists had a few different ideas about how the moon got here. Maybe Earth's gravity just snatched it as it was passing by, or maybe Earth and the moon formed together like siblings. There was even an idea that a super fast-spinning early Earth just flung a chunk of itself off into space. But none of these theories really fit all the clues. But today, the explanation that fits all the evidence is something way more dramatic. It's called the giant impact hypothesis, and it suggests our moon wasn't captured or born alongside us. It was forged in a collision of unbelievable scale. So let's set the stage. About 4.5 billion years ago, you have our young, molten proto-Earth. And then you have another object, a protoplanet about the size of Mars, that we've named Theia. And they were on a collision course. There was no stopping it, and this impact was going to change absolutely everything.
The collision was, well, world-shattering in the most literal sense. The heavy iron cores of Earth and Theia actually merged together. A huge cloud of vaporized rock and debris was blasted out into space, into orbit around Earth. And over time, gravity did its thing, and that cloud of debris coalesced to form our moon. But here's the kicker. That's not all it did. The sheer force of this impact knocked Earth sideways, giving us our 23.5-degree tilt. And that tilt? That's the reason we have seasons. No impact, no seasons. Just incredible.
Okay, so after the moon was formed and the constant bombardment from space finally started to calm down, Earth could finally begin its next great transformation, the journey to becoming a place where life could actually exist. As things cooled down, a really important process called planetary differentiation took place. Think of it like a salad dressing separating. All the heavy stuff, like iron and nickel, sank down to the center to form the core. The lighter, rocky materials floated to the top, eventually forming the mantle and the crust we live on. And this is absolutely crucial, because the churning, liquid outer core created by this process is what generates our planet's magnetic field, a protective shield that is the only thing protecting us from the sun's dangerous radiation. And we're talking about huge stretches of time here. From the fiery Hadean Eon to the next phase, the cooler Archean Eon, this whole process took over 2 billion years. It's just a mind-boggling amount of time. So after all that chaos and sorting and cooling, what do we end up with? We ended up with what scientists call Goldilocks conditions. It's not scorching hot like Venus with its runaway greenhouse effect, and it's not a frozen desert like Mars with its thin atmosphere. Earth is just right. Our balanced atmosphere, our liquid water, it's what makes this place a perfect home for life. When you step back and look at the whole story, from a random supernova explosion kicking things off to a giant planetary collision giving us our moon and seasons, it's just one incredible, unlikely event after another. I love how one source we looked at put it just perfectly. Everything that happened was exceptionally fantastic. So this incredible journey from a simple dust cloud to a vibrant, living world, it's really a story of cosmic luck and amazing resilience. And I think when you understand that story, it leaves us with a really profound question. How do we take care of a planet that is so rare, so wonderful, and so precious?